example 5 on page 558, expressed in terms of I. This example is square root of negative 48. By looking at this square root, it has the radicand negative, right? The radicand is negative 48. We learned in the previous sections that when you take square root of a negative value, the answer is not a real number, or does not exist as a real number. So square root of a negative value does not exist as a real number. Or in the case where you have negative radicand and the radical has k, the index k right here is even, in this case k equal 2. But remember, k can be 4, 6, 8, or any even numbers. Now, if you have negative radicand, again, when you take the radical of that index, k root, that's our even, the answer is not a real number, or a real number doesn't exist. Okay? So, when you see something like this, where the index k of the radical is even, and you have negative radicand, that means the answer is going to be in terms of I, or complex number. So, to solve this, you will try to rewrite this given radical in terms of radical of negative 1, because once you have this, you can convert this to I. So, I'm given with square root of negative 48. I can split this one radical to two radicals. So this, I can rewrite this as negative 1 time. Now let me actually show you one more step before I do that. So this negative 48, right, the radicand, I can split to two factors, 1 times 48. So negative 1 times 48 is negative 48. And from here, I can split this one radical to two radicals. When these two factors combined by the multiplication or division, you can split the radicals. So I'm going to split it to two radicals. Negative 1 times radical or square root of 48. Okay? Now, when you see this, square root of a negative 1, square root of negative 1 is equal to I. Okay? This is by definition. I is equal to square root of negative 1. So I'm going to replace this with I. Okay? By definition of a complex number I. For this, alright, this is not a prime number, so you can factor out this to find all the possible primes factor. So 224, you can factor two more. 1, 2, another 2, and you have 6, and then another 2, you have 3. So 1, 2, 3, 4, you have 4, 2, and 1, 3. So the factors of 48 are 2 to the 4th power, because there are 4 2's times 3. Okay? Let's see. So I'm going to write all these. I'm going to write 2 to the 4th power times 3, which is 48. I'm going to replace this to the 48 in here. Okay? So 2 to the 4th power times 3. Okay? Now this, again, you can split if you wish. You can split this to 2 to the 4th power times square root of 3. Now, you learned this before. A raised to the n power, raised to the n root. You can simplify this to a m divided by n. Okay, we'll learn about this a while back. So for this, square root of 2 to the 4th power, you can use this formula to simplify this to 2 raised to the 4th power divided by the index with the 2, index of the radical with the 2. Okay? Alright, I'm going to replace this square root of 2 to the 4th power with this. Okay? So, I times this one is replaced with 2, 4 divided by 2 times square root of 3. Okay? And then let me continue the problems here. Equal I times 2. The exponent 4 divided by 2 is 2. And then the remaining factor is radical 3. Simplify, you have I times 4 times square root of 3. Now, normally, for a complex number, we like to write I at the end of the factors. So I would like to write this as 4 square root of 3, okay? And then I at the end. Okay? So the answer for example 5, after you take square root of negative 48, is 4 times square root of 3 times I. And for complex number, usually we leave the I at the end, okay, after everything else. So everything else you see, put them in front of the I, of the letter I.